Hello guys, welcome back to my YouTube channel. As you all know me, this is Arshini with the USN 1VE23 EC011 studying at Sri Venkateshwara College of Engineering, Bengaluru. Currently pursuing third semester in the Department of Electronics and Communication Engineering. My today's subject is Digital System Design using Verilog with the subject code BEC302. And my today's topic is illustrating Quinn-McClusky method of five variables through example. Now let us see the introduction to the Quinn-McClusky method. The Quinn-McClusky method is a systematic approach for minimizing Boolean functions. It is particularly useful for functions with large number of variables like 5. This method provides a way to efficiently simplify logical expressions and truth tables. Let's see the overview of Boolean functions. A Boolean function is a function that returns true or false based on input values. It can be represented using a truth table or an Cargnu map, that is a K-map. The goal of minimization is to reduce the complexity of these functions while preserving their outputs. Now let us see the examples for Boolean function. Consider the Boolean function f of a, b, c, d, e. Let us consider this as a one Boolean function. It is defined by the minterms 1, 3, 7, 15 and 31. This function has five variables. As you see, this function has five variables, that is a, b, c and d. A, b, c, d and e. The corresponding minterms represents the combinations of variable values that makes the function true. If we solve this Boolean function, we'll get the minterms 1, 3, 7, 15 and 31. We'll get the minterms as 1, 3, 7, 15, 31. We'll get these minterms, and as you see here, this Boolean function contains five variables, that is A, B, C, D and E. This is one of the example for Boolean function. Now let us see, now we have seen the introduction for Quinn-McClusky method and also examples of Boolean, one of the example for Boolean expression or Boolean equation. Now let us see what are the steps to solve the Quinn-McClusky method. Here the first step is creating the truth table. We have to create the truth table for the given Boolean function. First step is to list the minterms in a truth table format like this. Like this, you have to list the minterms given in the truth table, and each row in the table corresponds to a combination of variable values. For our example, we'll mark the rows for minterms, that is 1, 3, 7, 15 and 31. That is 1, 3, 7, 15 and 31. Only for our reference, for our example, let us mark those minterms. Basically, here's the first step is to create the truth table for the given Boolean expressions. Okay, and the next one is, and the next step is group minterms by number of ones. That is, we have to group the, after writing truth table, we have to group the number of ones in their binary representations. Based on their binary representations, we have to group the number of ones. That is, if minterm of that is, see, if here the minterm 1 is 0, 0, 0, 0, 1, it has 1. in this minterm or in this binary representation we have 1. So in minterm 3, in minterm 1 we have 1, and for example in minterm 3 we have 0 0 0 1 1. In this it has two ones, it has, as you see, it has two ones, and so on. Like this you have to group the number of ones in the truth table. So that this helps us to in finding the next pairs of minterms that can be combined. And the next step is combine minterms. That is, we have in the second step we have grouped the number of ones. We have grouped the number of one minterms, right? Now we have to combine those minterms. For example, to make we have, if we have grouped 1 and 3, we have to combine those to form like 0 0 0 0 until 1 0 0 to 1, so that we'll get a dash b dash c dash d expression. So we have to combine until no further combinations are possible. This process will continues until combinations are not possible. And the next step is constructing prime implicants table. After combining, we create a prime implicant table to track which minterms are covered. Each prime implicant is listed along with the minterms it covers. This step is crucial for determining essential prime implicants in the next step. We have to construct a prime implicant table by using K-map. As you all know to you how to write the K-map, we have to construct the prime implicant table in the same way and see which minterms are covered, so that we can in the next step we can determine the essential prime implicants. And the next step is identifying essential prime implicants. That is, after constructing a prime implicant table, we have to identify the essential prime implicants. That is, we can check each minterm in the table to identify these essential prime implicants. For example, we find which implicants are necessary to cover all minterms. That is, which implicant is covering all minterms, so that will consider those minterms as essential prime implicants. And at last we'll get the final expression. The final step is to write the minimized Boolean expression using the essential prime implicants. These expressions will be the simplest form of the original function. The output will have fewer terms and be more efficient for implementation. And at last, conclusion and application. The Quinn-McClusky method is a valuable tool for simplifying complex Boolean functions. Its structured approach ensures that all possible simplifications are considered. This method has practical applications in digital circuit design and optimization. And at last, thank you for watching my video. Please like, share and subscribe to my channel.